Today we'll prove that the square root of 2 is irrational. It cannot be written as a ratio of two integers. This is a fairly simple example and a great introduction to the idea of mathematical proof, specifically proof by contradiction. For a number to be irrational, there must exist a ratio. Let's say some p or some q, or p and q are integers, and q is not equal to 0. So let's suppose that the square root of 2 is equal to some p or some q. Now, this fraction can be written in many forms, just like how 1/2 is the same as 2/4, which is the same as 3/6. But since we haven't chosen any specific values for p and q, any property we discover must apply to all equivalent forms of this ratio. So going forward, we'll assume the ratio is in lowest terms, meaning there is no number other than 1 which can divide both p and q. Now, if we take our p or q, which is equal to the square root of 2, square both sides, we get p squared or q squared is equal to 2. And if we multiply both sides by q squared, we get p squared is equal to 2 times q squared. This equation tells us that p squared is even, as is equal to 2 times some integer number. But if p squared is even, then p itself must also be even. Well, because if p were odd, then some p equal to 2x, where x is some integer, plus 1, where this is the definition of an odd number, squaring this number gives us 4x squared plus 4x plus 1. This is the same thing as writing 2x squared plus 2x plus 1. Now, of course, if you take some even number, the definition of an even number is just 2 times some integer x squared. You get out 4x squared, or 2x squared. That means that p may be written as just 2 times some integer a. If we plug this into our equation, we get out 2 times a squared is equal to 2 times q squared. This can be simplified as 4a squared, 2q squared, and then 2a squared is equal to q squared. So now we found that q squared is even, which means q is also even. But here is a contradiction. We assume that p and q have no common factors. Yet we've just shown that both p and q are even, meaning they are both divisible by 2, a common factor. The only thing we assumed was that the square root of 2 could be written as a fraction p over q in those terms. Since that led to a contradiction, our assumption must be false, and therefore the square root of 2 must be an irrational number.